Okay, so today we are going to see assignment number 7 of last year's course. We have already seen the first six assignments. So I hope my screen is visible. Can any?
Yes, sir.
uh, Okay, thank you, Shalini. So let's start. So we are going to see. So it's week 7, assignment 7 of 21 course, and we will have a discussion over it. Okay, so it is your first question. You can have a look at this question and uh, try to solve it, or just if you can give me some hints how we can proceed, then it will be better. So it says if z double bracket t is the formal power ring of uh, over z, which of the following is the inverse of this function ft summation of I equal to 0 to infinity 3t raised to I in this ring? 1 minus t, 1 minus 3t, or the power series from 1 to infinity minus 3ti, or it does not has an inverse. So I hope the definition of ring of formal power series is clear to you guys, and you know the how the multiplication is defined on that series, on that ring. If yes, then you can try to solve this question. So I'm just recalling the product. So it is, say, summation of an, or if n equal to 0 to infinity, this is multiplied with summation of bn n equal to 0 to infinity. Then we get some power series Cn, such that Cn is defined in this manner: k equal to 0 to n ak b n minus k. Okay. Now using this definition, can you find the inverse of uh, given s- series? Yes. Any comments? No.
No, sir.
Okay. So let me try it of my own. So ft is given to be summation of t equal to 0 to infinity 3t raised to I, which is same as if I write it t equal to 0 to infinity 3 raised to I, oh, 3 raised to I and t raised to I. Okay, so it's a power series in with the coefficients in z, that is integers. So let gt, which is, say, t equal to 0 to infinity, let us define the coefficients to be a, a here it should be I, not t. It's I equal to 0 to infinity, I equal to 0 to infinity. Here it also should be I equal to 0 to infinity. So it is coefficients ai, then ti be the inverse of ft. Then we must have ft dot gt to be the identity of this series. What is the identity? It is just 1. All coefficients are 0 except the first coefficient, and first coefficient is just your 1. So this is the identity in this uh, ring of formal power series. So now let us see what it gives us. So this will implies that summation of I equal to 0 to infinity 3I ti dot summation I equal to 0 to infinity ai t raised to I is 1. Now if this is equal to your some summation of I equal to 0 to infinity of say ci ti, okay, then what you expect that c0 is just a0 times b0. b0 from here you can see, if I put n to be 0, so it is just k equal to 0 to 0, a of 0, b of 0. So it's just a naught b naught. So what is a naught here? A naught is 3 raised to 0, that is 1. Okay, so I'm writing directly to be 1. Sorry, this, let's say this is your summation bi ti, and this is your ai ti. So b naught is your 1, and we have no idea what is a naught, so it is just a naught, and that is 1. Okay, because your c naught here is 1. I can write that this will implies that c naught is 1 and ci is 0 for all I greater than equal to 1. So your c naught is 1, that is equal to 1 dot a naught, which will implies your a naught is 1. Okay, now what is your c1? c1 is, using this property, it's going to be mm, the coefficient. If you compare it with this, let me write some coefficient here. So c naught is just a naught b naught, c1 is a1 b naught plus a naught b1, c2 is a2 b naught plus a1 b1 plus a naught b2. Just see these indices. Their sum should be equal to the index of C. Okay. And similarly, your C3 is going to be A3 B naught plus A2 B1 plus A1 B2 plus A0 B3, and so on. You can get the other indices. Okay. So your C1 is A1 B naught plus A naught B1. Here it's going to be A1 times this series is our B series. So its first coefficient is 1 plus A naught times B1. That is the second coefficient of this series. That is 3 raised to 1. So it is 3, and that is 0. C1 is 0, right? Wait, and you already know the value of a naught, that is 1. So 1 dot 3 equal to 0, which will implies a1 is minus 3. What about rest coefficients? Now c2 is a naught, the second coefficient of the above series, that is 3 square, sorry, third coefficient here, a1 b1, that is 3 raised to 1, a2 b naught, that is 1, and this is also 0, right? C2 is 0. This will implies 9 a naught plus minus 3 times, I should not write this value now, 3a1 plus a2 is 0. Now put the values of a naught a1, this is 9, a naught is 1, a, a1 is minus 3, so it is minus 9 plus a2 equal to 0. This will implies that your a2 is 0. Okay.
Yes, sir.
Okay, so what can you say now for other coefficients? I will calculate C3, then through induction you can find what is the value of AN, Cn. So C3 is going to be A naught 3 cube plus A1 times 3 square plus A2 times 3 plus A3 times 1, and that is equal to 0. So this will implies A naught is your 9, sorry, 1, 1 dot 27. So A1 is 3 square, sorry, minus 3, that is minus 3 times 3 square. A2 is 0 plus A3 equal to 0. This will implies 27 minus 27 plus A3 is 0. So your A3 is going to be 0. So similarly, you can get that your Cn, that is A naught, A naught times 3 raised to n plus A1 times 3 raised to n minus 1 plus A2 times 3 raised to n minus 2, so on to A n times 3 raised to uh, that 3 raised to 0, that is 1, equal to 0. So if A2, A3, A4, so on to the coefficients till an minus 1 is 0, then what will you have? You will have Cn to be A naught is your 1, 1 dot 3n, A1 is minus 3, minus 3 times 3n minus 1, and then from A2 to an minus 1, everything is 0. So you will be left with an only. So it is plus 0 plus 0 dot 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 plus 0 plus an is 0. This will implies that 3 raised to n minus 3 raised to n plus an is 0. That is an is 0 for all n greater than equal to 2. Okay. Here also I am assuming n to be greater than equal to 2. So what you get? Your function gt is this. So after 2 you are getting 0, a naught is 1 and a1 is minus 3. So this will implies that gt, that is summation of I equal to 0 to infinity ai ti is 1 minus 3t plus 0 plus 0 plus 0. Everything will be 0 after a2, right? So that is just 1 minus 3t. You can check that it's an option there. So 1 minus 3t is the correct option. Inverse is unique, so we need not to look at the other options. Okay, does it make sense?
Yes, sir.
Okay, if it is fine, then the next question I will give to you. Uh, it's easier than this. Still, you need to check that whether it's correct or not. So at least the definition of formal series is clear, right?
Yes, sir.
Okay, and I think you guys can do the next question easily. Let me just write it. So you can see this question. Let Zt denote the formal power ring in over Z. Which of the following is the inverse of Ft? The function has been changed slightly. Here the first uh, coefficient is 0 and the series is same. So now can you say something about the whether the inverse exists or not? If it exists, what can be the inverse? Certainly, it's not going to be 1 minus 3t, because if uh, the inverse is unique, so the inverse of inverse is also unique. So if 1 minus 3t was the inverse of your previous function, so it can't be the inverse of this function, right? So one option is you can directly neglect. Now, uh, from the rest three, what can you say? Do you guys want to try it for a while?
Yes, sir.
Okay. Yes, Shalini, any inputs?
सर आई हैव अ डाउट कि जो इसके इनवर्स वाली सीरीज लेनी है हमने उसका जो इंडेक्स है वो 0 से स्टार्ट करना है या फिर 1 से।
वो जीरो से स्टार्ट करोगे ना, बिकॉज ये तो जनरल एलिमेंट लेके चलोगे आप ऐसे ही. लेट जी टी बी द इनवर्स ऑफ एफ टी, राइट?
यस सर यस।
तो ये जीरो से स्टार्ट करनी है.
वैल्यू ऑफ ए नोड इज 1।
A naught is 1. Okay, let me check. So ft gt is identity. So summation of I equal to 1 to infinity 3 raised to I t raised to I dot summation of I equal to 0 से infinity, ai ti is 1. Same thing we can say, uh, if that this is equal to your summation of I equal to 0 to infinity CITI, then that will imply C naught is 1 and Ci is equal to 0 for all I greater than equal to 1. So yes, C naught क्या होगा? From here C naught is A naught times the coefficient of this, constant coefficient of this. What is the constant in Ft? 0,
Zero.
right?
Yes, sir.
And this C naught is equal to 1. So this will imply that your 1 is equal to 0. Can it happen?
No, sir. No.
No, right? So it's a contradiction. Thus, the inverse will not exist. This will implies inverse of Ft does not exist. And you can say, see, it's an option there. So the element has no inverse. It's the same thing. Okay. So how, Shalini, you were getting a naught to be 1?
Sir, actually, I am confused in index. One index is starting from 1 and other is starting from 0. So multiplying them is little bit confusing for me.
Okay. So beware of these kind of mistakes. These are common mistakes. We also used to do that when we were dealing with these things for the first time. So
Yes, sir. This topic is very new for me. I have learned this first time. इसलिए अच्छा नहीं लग
okay,
रहा है मुझे.
formal power series.
यस सर, इस वीक जो भी है इस कोर्स में वो सभी फर्स्ट टाइम ही है, मतलब जैसे वो है पाथ अलजेब्रा वगैरह ये सब कुछ
पाथ
न्यू
अलजेब्रा
है.
ऑफ ए क्यूबर. ओके.
यस.
ठीक है, अगर टाइम बचा तो देन आई कैन गिव यू सम आइडिया ऑफ पाथ अलजेब्रा ऑफ क्यूबर. Let's deal with these assigned questions. Okay. So this is the third question. Which of the following is the field of fractions of uh, this polynomial ring? So I hope field of fractions, you know.
यस सर.
Okay. So just for the sake of recalling, I can write its definition again. So field of fractions of an integral domain. To define the field of fractions, we need the ring to be in an integral domain, and Z is an integral domain, so its polynomial ring is also an integral domain. So we can talk about the field of functions of this ring, Z, polynomial ring over integers. So it is, first definition says that it is the smallest it is the smallest field containing, let me denote it with something, mm, let's say D, the smallest field containing D, or in other words we can say it is the smallest field in which D can be embedded, because up to isomorphism also we can see the rings. So it, as a subset, it might not be visible, but if there is just some injection, some injective map, then we say that it's been embedded in that field, and it has to be the smallest field such that D can be embedded. So first definition is this. Second is when we try to define, construct it explicitly. Okay. For this we need uh, an equivalence relation. Define an equivalence relation on the set B cross D minus 0. 0 and D are looking exactly the same. So it is D minus 0. Correct this also. Okay. In the following way. So, let's see. So how we are defining the equivalence relation? So a tuple A comma B is related to a tuple C comma D if
AD equals to BC.
yes, AD equal to BC. Thanks, Shalini. So now let's say F is the set of equivalence classes of set of equivalence classes, okay, of this relation, uh, this. Then you can define or first of all, before that I should write one more statement, that let A by B denotes the equivalence class or just class of AB. So if F is a set of equivalence class of this, define the addition to be like this: AD plus BC divided by BC, and the product is just,
BD.
yes, thank you, Shalini. So it has to be BD. So it's just how you multiply the fractions
Yes, sir.
AC by BD. So with these relations, it forms a field F. Or simply I can write F plus dot is a field, and this field is named as field of fractions. Now let's go back to the question again. Which of the following is the field of fractions of ZT? So first option is trivially and satisfies the definition, that is rational functions with integer coefficients. So let me just write it. What the first option is ZT rational functions with integer coefficients. What does this? What are the rational functions? They are just the functions of the form ft gt, such that ft belongs to your z of t and gt belongs to zt minus the 0. So by the definition of field of fractions, it is going to be the field of fractions of the polynomial ring, right?
Yes, sir. Yes.
But there is something more. The second option is also correct. Rational functions with rational coefficient. I can tell you why. So q of q of t, the rational function with coefficients in q. It is also the same thing. Why? Because see, you can see that zt is inside qt, right? This function, if it has integer coefficients, then it has rational coefficients. Same, this has integer coefficient, then it has rational coefficients. So any function of this form is going to be inside this qt, right? So zt is inside qt. Now from qt to zt, you can define a map. How? So uh, let's say ht times maybe k of t. It's a it is inside qt. Then what can you do? Then let alpha and beta be the LCM of denominators of coefficients of HT and KT respectively. Okay. So see, this function alpha dot beta dot k of t, it is inside z of t minus 0, of course, because kt is non-zero. So its coefficient of its denominator is going to be non-zero, and alpha, uh, anyway, denominators cannot be zero, otherwise it will be well defined. Won't be a well defined fraction, right?
Yes,
So
sir.
So alpha, beta and are non-zero, and kt is also non-zero because we need this denominator to be non-zero. So alpha, beta, kt is inside z, is non-zero first of all. Why is it inside zt? Because once you apply beta with kt, as it is the LCM of your denominators of this kt, so it will after multiplying, if you multiply with individually with each coefficient, then it will cancel out the denominator part and only the numerator part will be left. uh, can you
Yes,
get it
sir. Yes, sir.
clear, right? So
Yes, sir.
it belongs to zt, and alpha times this will also be inside zt because alpha is a integer. So this is inside zt, and now if I multiplied alpha, beta, kt with the given function, that is ht times kt, then this will be inside your z of t. Now see, this kt will cancel out this kt, both are non-zero, so we can do this, right? uh, Alpha uh, multiplied with this ht, alpha is the LCM of denominators of ht. So alpha when multiplied with ht will give you an element of zt, right?
Yes, sir.
Okay, so this this term is inside zt, and this was inside your q, but when these two are multiplied, then it's giving you an element of zt, right? So there is something called denseness property, which is nothing but something to guarantee your surjection. So if for all uh, f inside your field of fractions, there exists some d inside your integral domain such that uh, f dot such that d dot f belongs to, it should be non-zero. Just a minute. D dot f belongs to uh, the, just a minute, I need to say, yes, it should be again inside D. Then we say that f is the field of fraction of t. Okay. See, for each integral domain and the field of fraction, integral domain is naturally embedded inside the field of fraction by the definition itself. It's the smallest field that in which d can be embedded. So d is already inside your f, right? Now what we are trying to do, somehow we are trying to see the surjection part. So if for all f in a field f, if there exists some d in some non-zero d in the integral domain such that their product is inside d again, then f is set to the field of fraction of t. So what we did, we pick an element of qt, right? Corresponding to it, we get an element of zt such that this element of zt multiplied with this gives you an element of, should be inside zt again. So
Yes, sir.
okay, so it tells you that it is a field of fraction Qt is a is the, you can say, because they are isomorphic. All field of fractions are isomorphic. It is the smallest field basically. So Qt is the field of fraction of zt, right? So Qt and zt both, you can say, are field of fractions of zt. Okay, so first and
Yes,
second
sir.
option are correct, and third option is not correct because these two are not isomorphic, Qt and Qt. So it cannot be the field of fractions for zt. Okay,
Yes, sir.
so it is one of the interesting problem in this tutorial. Now we will see the fourth one. Fourth one is easy. Let me just write the question. Shalini, I leave it to you to answer this question. I hope you can answer this. It says that if let A and B are two integral domain with fraction fields K and KB, and you have this inclusion, then what can you say about KA? Are Kn and KB isomorphic? You just need to use the definition of fraction field. Even if you don't know the second definition, you can just use that it is the smallest field containing the integral domain.
Sir, it is true.
Yes, why?
Sir, Ka is the smallest field containing A, but here B contains A.
B is not a field.
Oh, yes.
We need to see the relation between K and KB. Do you agree with me on this? A contained in B, therefore the fraction field of A will be contained in fraction field of B.
Yes, sir. Smallest field.
Okay. Now you don't need to use the smallest part. It's just uh, some kind of rationalization of this integral domain, and it's a rationalization of this integral domain. So by the definition of K and KB itself, it will come. What KB is? KB just contains the rationals uh, from B, and K contains the rationals from A. So if A is contained in B, then K has to be contained in KB, right?
Yes,
Okay.
sir.
What about the reverse? See, since your B is inside KA and B is also inside your KB,
Yes, sir.
now you should use the smallest thing. B is inside AB and KB is the smallest field. Is the smallest field containing
B.
B. But KA also contains B.
Yes,
So
sir.
you must have KB inside KA.
KA.
So what can you say about first and second? It will implies KA is same as KB, or you can say they are isomorphic because uh, you should not write KB as a subset is a subset of KA. You should write that it should be embedded inside your KA, right? Okay. So they are isomorphic, so the statement is true. This question was an easy one. Let's check the next one. So it says let RA and CA denote the row space and column space of a matrix A respectively. Which of the following holds for all matrices XY in M and Q? So let me tell you some facts or observations. Let's see. So row space of A is same as column space of A transpose. You agree? Because if you take the
Yes, sir.
uh, A transpose, then rows will be changed to columns and columns will change to rows. So it is this, right? Now, if now corresponding to each matrix, you can define a linear map, right? Let T be the linear map corresponding or T of A linear map corresponding to A. Then the column space of A transpose is same as the range of this TA. You can check it. For small matrices, you can check and then realize that this is true. Okay. Now,
Okay, sir.
okay. So what we can do next? Also, I think should this observation should be clear to you directly. The range of some polynomial maps ST is contained inside the range of S. Do you agree?
Yes, sir. This is.
See, ST of V is nothing but S of T of V, right? So it has to be inside the range of S, right? Okay, then. Now the thing should be clear. So what they are saying, the row space of XY. So let us see row space of XY, row space of XY. Uh, this is nothing but the column space of XY transpose, which is column space of Y transpose X transpose, right?
Yes,
And
sir.
this is equal to the range of the polynomial T. I make mistake. Here it should be T of A transpose. Uh, hmm, okay. So column of A is equal to range of TA. So range of T. What is the matrices here? Y transpose X transpose. So it is same as range of T Y transpose T X transpose, because it's a homomorphism. Now, for each matrix you can assign a linear transformation, and for each linear transformation you can assign a matrix. This is a homomorphism, right? So we can separate them now. T is that assigning map, sending a matrix to the corresponding linear transformation. Range of this. Now use this. Range of ST is contained in range of S. So it's going to be contained inside range of T Y transpose, and that is same as column of Y transpose, and that is same as row of Y. Okay, so all this leads to the observation that row space of xy is contained in row space of y. Okay, you can look at it for a while and let me know if any relation troubles you, or you have any doubt in any relation.
Clear, sir.
Okay, so let's move ahead. We need to see the same thing for column. Column of xy is simply the range of txy. Again, use the homomorphism property of this assigning. It is going to be tx dot ty, and then the containment part is going to be inside a range of what? What should come here?
TX.
Yes, tx. And now can you complete what it should be? C of x, right? Is- Yes, C of xy contained in C of x. Okay.
Yes, sir.
So that's what we are supposed to see, what containment is true. So for row space, the second one is true. For column, this first one. Okay. Okay. So you just look at it once. I'm just writing the question then. So here it is. If R is a non-commutative ring and I be a left ideal of R, J be a right ideal of R, we define the product of ideal in this manner. What is then what you can say about IJ? Shalini, any guess? तुक्का मारो क्या होगा?
Sir, in commutative ring, it is an ideal, but in non-commutative, I have to check.
Do you need commutative thing here? So simply take let I'm leaving it to you that this IJ is an abelian group. Okay.
Okay, sir.
Uh, Rather than abelian, I should say it's just a subgroup of R. Now I will just check the ring ideal property. Let R be inside R and say some mm, S belongs to IJ. Then S has to be of this form, summation of I k j k, k is from 1 to some index, what index they are using, n, right? So k equal to 1 to n,
And
such that your ik's are inside I and your jk's are inside j. Okay. So what is r dot s? It is just r times summation of k equal to 1 to n ikjk. Now if you multiply it with this, then you will get summation k equal to 1 to n r times ik dot jk. Now what can you say? This is inside this is inside I because I
I
is
is
a left
left
hand.
idle.
Yes, I is a left ideal. So r dot s will be inside ij, right? Because this part is inside I and this is already in j. That's how the ij product ij is defined. Now what can you say about s dot r? So it is summation of k equal to 1 to n ik jk dot s, that is summation of k equal to 1 to n ik jks. Now
सर
since
डॉट आर आएगा.
yes dot r आएगा. Thank you. Ravi, your mic is on. Can you please turn it off? Thank you. So jkr किस में j में चला जाएगा because j is a right ideal
यस सर.
और ये ऑलरेडी i में था तो पूरा पूरा कहाँ चला जाएगा ij में, right? This implies ij is a two-sided ideal. Finally, we are not using commutative thing anywhere, right?
यस सर.
So this is true in general. Okay. So if it is okay, then let me just write the next question. It's a true false question. It says that P and Q are integral domain. Then what can you say about P cross Q? A quick guess or quick answer to it. It's an easy question.
सर दिस इज फॉल्स.
Why?
सर वी कैन टेक टू एलिमेंट्स लाइक a comma 0 and 0 comma b,
Hmm.
and then uh, by multiplying them we will get 0. मतलब
Yes.
हम ऐसे दो नॉन जीरो ले सकते हैं p क्रॉस q में जिनको
Hmm.
प्रोडक्ट करने पर 0 बन सकता है.
Yes. Okay. Or you can just check that Z cross Z is not an integral domain.
यस सर.
Take this and is inside, I should have written that it is inside P, it is inside Q. This inside P and this inside Q. Then you have A comma 0 dot 0 comma B is 0 comma 0. So the statement is false, right?
Yes, sir.
Okay. So let's see the last question of this assignment. It says if P and Q are Noetherian rings, whether P cross Q is a Noetherian ring. So any guess whether this is true or not? कुछ भी to start with true, false, what your intuition says.
This is true.
This is true. Uh, any reason why it should be true? शालिनी कुछ आइडिया आ रहा है?
सर मैंने ऐसे सोचा है, मतलब गलत भी हो सकता है। जैसे
हाँ
पी और
हाँ,
क्यू नोएथेरियन रिंग्स हैं, तो बाय डेफिनेशन एक असेंडिंग जो है आइडल्स की चेन एग्जिस्ट करती है, जो कि इनफाइनाइट नहीं हो सकती। तो पी
नहीं,
क्रॉस क्यू के
डेफिनेशन में
आइडल।
दिक्कत है। रुको रुको रुको, नॉर्थेरियन रिंग मीन्स एवरी असेंडिंग चेन हैज टर्मिनेट्स। एक असेंडिंग चेन नहीं, एवरी असेंडिंग चेन।
ओके सर। एवरी।
हाँ, कोई
तो
भी इसमें असेंडिंग चेन लोगे तो वो टर्मिनेट होगी।
जी।
ठीक है।
और उसके बाद ये जो पी क्रॉस क्यू है, इसके जो आइडल होते हैं वो आई क्रॉस जे टाइप के रहते हैं, आई थिंक। जिसमें आई की पी का
ठीक है।
आइडल होता है और जे क्यू का आइडल होता है। तो अगर पी और क्यू के आइडल्स ऐसे टर्मिनेट हो रहे हैं, तो पी क्रॉस क्यू के भी होंगे ऐसे, मतलब मैंने सोचा। आई मे बी रॉन्ग।
ना ना ना, यू आर ऑलमोस्ट देयर, बट योर इंट्यूशन हैज टू बी वेरीफाइड मैथमेटिकली। ठीक है,
यस सर।
ऐसे नहीं लिख सकते कि ऐसा हो रहा है तो वैसा भी होगा, राइट?
सर दिस इज माय प्रॉब्लम। कॉन्सेप्ट इज क्लियर बट डोंट नो हाउ टू एक्सप्लेन।
नहीं ठीक है, इतना भी एटलीस्ट फर्स्ट फर्स्ट स्टेप इज ऑलवेज योर इंट्यूशन।
यस सर।
Okay. So let's write a formal proof to it. The statement is true. You are right in that. So let's start. So I will say let I1 contain in I2 contain in I3 dot 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 be an ascending chain in P cross Q. Okay. So this will implies that I1 intersection with A contain in I2 intersection in A contain in I3 intersection in A dot 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 is an ascending chain in A, right? You agree?
यस सर। सर इट शुड बी पी और ए।
yes, 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 yes. A cross B वाला notation चल रहा था मेरे mind में. Yes, it should be P. Thanks. So it is P, P, P. Yes. ठीक है. So it's an ascending chain in P. Now, since P is a Noetherian ring, P is a Noetherian ring, this will terminate. Therefore, there exists some I such that I T intersection P is equal to I intersection P for all T greater than equal to I. So it terminates at I. Now here we have used the Noetherian property of P. We are also given that Q is Noetherian. So to use the Noetherian property of Q, define the projection map pi 2 from P cross Q to Q as simply the usual projection you might have seen it. It is just sending an element small pq to Q. Okay. Now I leave it to you guys to check that this pi 2 of I1 is an ideal, pi 2 of 2 is an I2 is an ideal, and then so on. Each element is an of this above chain was an is an ideal. Projection of these ideals is an ideal, and the ascending chain is condition is preserved. Okay,
Yes, sir.
is an ascending chain is an ascending chain in Q. Now Q is a Noetherian ring. Hence Q is a Noetherian ring. So this also terminates at some point. Therefore, their edges say some j such that pi 2 of ij is equal to pi 2 of it for all t greater than equal to I. Okay. Now here it intersection P was equal to I. It was terminating at I. Here it is terminating at J. It should be, we should have J here. So we can take the maximum of these two indices. Let K be the maximum of these indices. Then after K, what happens? They both are stabilized. Pi 2 of IT is equal to pi 2 of IK, and IT intersection with A is equal to IK intersection with A for all T greater than equal to K. ठीक है? Is it clear?
Yes, sir.
Okay then. Now we will go back to this I1 I3 chain again. So our claim is that after this K, ik is stabilized. Okay, so let's see how we can do that. Let uh, AB belongs to IT for some T greater than equal to K. Or I can write strictly greater than K. Then what can you say? Before going to that, let me write it like that. Just changing the way of writing. So let's start like this. Let T is greater than K. So then IK is contained in IT. Can anyone say why?
This is ascending chain. Na?
Yeah, this is ascending chain. So T is greater than T. IK has to be contained in IT. So if we can prove that IT is contained in IK, then we are right. And then we are done, right?
Yes, sir.
Uh, and let this A comma B belongs to IK. Then mm, A belongs to A and B belongs to B. Again, I am going with these notations. A belongs to P, B belongs to Q.
Sir, we have to take element from IT na.
Ah, yes, 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 Shalini, thank you. So, IT and uh, what can you say about its intersection? Just a minute. Yes, pi 2 of AB is B, right?
Yes, sir.
And we also have pi 2 of IT equal to pi 2 of IK, right? Because after K, this projection series is stabilized, right? Due to
Yes,
this.
sir.
Okay, so this implies that B belongs to pi 2 of K, pi 2 of IK. Okay, so what can you say now? Now consider this element. We somehow have to use the intersection one also. Just give me a second. Intersection A. Okay. Now, okay, pi 2 of AB is equal to B. It is equal to pi 2 of some mm, A dash B. Can we write like that? Cos, but what is the motive? Okay, so like this is inside your IK, or uh, let me write like this. This implies this. Now let A dash be such that A dash B belongs to IK and pi 2 of a dash b is b, right? Why I can write find this a dash? Because see, b belongs to the projection of ik. That means there is some tuple a dash comma b inside ik such that its projection is b, right?
Yes, sir.
So that's what that element I'm naming at a dash. Let a dash be such that a dash comma b belongs to ik, and pi 2 of this belongs is b, and this a dash is inside a, right? Because first coordinate is always inside a. Now what can we do with this a dash? This a minus a dash comma 0, it belongs to I of t, right? Why? Because a comma 0 belongs to I of t, and a dash comma 0 belongs to ik, which is inside your I of t. So this belongs to it, and this is also inside your a, right? Because a minus why I'm writing a, it has to be your p, right?
Yes, sir.
So this is inside your p, this is inside your p. This will implies that a minus a dash 0 belongs to it intersection with p, which is same as it intersection with, sorry, ik intersection with p. Now, how we can use this part? This is a minus a dash of 0 intersection inside your ik. Now what is this a comma b? It is a minus a dash comma 0 plus a dash comma b. This was already inside your ik, right?
Yes, sir.
And this somewhere we have made this mistake in this middle step. I'm just correcting it. So we just need to show that a minus a dash is inside ik, right? A dash comma b is inside ik. So if we can show that a minus a dash comma 0 is inside ik, then this will implies, I will show that if I can show that this is also inside ik, then this will implies ab is inside ik, and that will give you that it is inside ik, and thus it is equal to ik
IK.
for all t greater than equal to k, right? And that will imply that your p cross q is a Noetherian ring. Okay, so modulo this observation that a minus a dash comma 0 is inside uh, I, ik, we are done, right?
Yes, sir.
Okay, so now let's see how we can prove that this is inside ik. So a minus a dash comma 0 is Has to be inside. Okay, so this is inside. How we are taking. So both of these elements are inside A, right? A minus A dash, comma.
Yes, sir.
Okay, so this has to be inside. Again, same. I am confusing with A and P, so uh, please forgive me for that. So it is inside your P
P.
intersection with I T, right? And because this is inside your P, A is inside your P, and A dash is also inside your P, so it is inside your P, right?
Yes, sir.
Okay, and A dash was inside uh, A dash comma 0 was inside your IT, and A minus 0 is also inside your IT. So this is in the intersection, and this is same as P intersection with IK. Because of this second termination, you write it IT intersection P or I P intersection IT, that is same. So this sequence also terminate. This is inside your P intersection IK, right? And that will implies A minus A dash comma 0 is inside IK, right? Because if it is in the intersection, then it has to be inside IK. So let me just quickly recollect all the things, because I think I have made you guys confused a bit. Yeah. So we need to show that if P and Q are Noetherian rings, then P cross Q is also a Noetherian ring. So we start with the ascending chain in P cross Q. So we first observe that if we take the intersection of individual ideals with P, then it's again a ascending chain, but it has to be inside your P. Since P is an Noetherian ring, so there exists some index I such that this ascending chain terminates. So IT intersection P is same as II intersection P for all t greater than equal to I. Is it clear till now?
Yes, sir.
Okay. So then we define the projection map from P cross Q to Q, and we take the projection of this ascending chain. So this projection is pi 2 I1, pi 2 I2, pi 2 I3, and this projection preserves this ascending chain condition. So it's an ascending chain in Q. Now since Q is a Noetherian ring, so this ascending chain also terminates somewhere, say J with such that pi 2 Ij is pi 2 It for all t greater than equal to J. So if we take the maximum of these indices I comma j, then after that index k, both these sequences, both these chains are uh, stabilized. So pi 2 it is pi 2 ik, and it intersection a is ik intersection a for all t greater than equal to k. Now we claim that for this k, the initial chain in this I R's, this ideals I1, I2, I3, this initial chain should stabilize after this k. So we take something greater than k, then definitely due to ascending chain condition, we have ik inside your it, and we pick an element ab inside it such that a is inside p and b is inside q. So due to projection, projection of ab is b, and projection of it is same as projection of ik due to the stabilization of our projection chain. So we have B is inside pi 2 of ik. Since B is inside the projection of ik, so there exists some element A dash comma B inside ik such that pi 2 of A dash comma B is B. And this A dash has to be inside the first Noetherian ring, that is P. Now what we did, we take this tuple A minus A dash comma 0. This has to be inside P intersection with IT. Okay. So by P intersection IT, I mean uh, intersection with P cross 0, you can say, because it's up to isomorphism. So it might be because P is also sitting inside P cross Q na, as an embedding.
Yes, sir.
So as a set, it might not make sense. So let me just make it more clear. So let it be some P dash chain in P dash, which is uh, nothing but P cross 0. Okay. So P is a Northern ring. So P dash is just isomorphic to P. So P dash is a Northern ring. So, so you can make the changes accordingly. For projection, we don't have any issue. Projection is in inside Q, so it makes sense. Here also I'm writing A. So this is because I usually prefer A and B notation, because you can take the element as A comma P. P and Q are sometime uh, uh, we get confused through the prime elements. So that's why A
Yes,
comma
sir.
B is,
Yes.
yeah. So इसलिए वो A comma B में क्वेश्चन सॉल्व किया था. That's why the question problem is arising. But okay. So A is inside. Yeah, this is clear, I guess. Even in here. So here also it should be P dash intersection with IT and P dash intersection. So uh, so this is inside your P dash, right? This is an element of P, and P cross it is 0. So we have it's an element of P cross 0, that is P dash, right?
Yes, sir.
And it is also an element of IT, because A dash is inside P. You can check why it is an element of IT. See, the other way to check is this. Why is it inside IT? See, A minus A dash first of all belongs to P. This will implies that A minus A dash comma 0 belongs to P dash. Now, what is A minus A dash comma 0? It is just A minus A comma B minus A dash comma B. And A comma B we have chosen to be inside IT, and this is inside IT by our assumption, and this is inside IK, right? A dash comma B is inside IK, right? And we have chosen A comma B to be inside IT. So it both of these is inside IT, so the difference has to be inside IT. Maybe now it is more clear why this is
Yes,
in the
sir. Yes.
intersection. Okay, so this is inside the intersection P dash intersection IT, and we have already seen that this sequence, this ascending chain also terminates. So it is same as P dash intersection IK, but that will implies that A minus A dash is inside a comma 0 is inside IK, because if it is in an intersection, then it has to be inside your uh, IK. Now AB can be written as A minus A dash comma 0 plus A dash comma B. This is inside IK and this is inside IK. ठीक है, ये यहाँ पर अभी हमने यहाँ देखा, this is inside IK and A dash comma B is inside IK from here. You can see that we need to write this element as a sum of two elements, and the first element we get it inside IK due to the termination of this projection series, projection chain, and the second element is obtained due to the termination of this intersection uh, chain. That's why we in the beginning I started by showing that both of these three chains terminate using the Noetherian property of P and Q. Okay, so their addition is A comma B. This is inside IK, this is inside IK, so this implies that A comma B is inside IK, and thus IT, as A comma B is an arbitrary element of IT, so IT is inside IK. This implies IK is already inside IT, so this implies that IT is equal to IK for all t greater than equal to K, and thus P cross Q is a Noetherian ring. Okay, does it make sense? It's an interesting question.
Yes, sir.
ठीक है, so Shall I repeat it once or it is clear?
Sir, in last step, there should be P dash or P. Should be
There.
here. Green one. P. ठीक है P. P
Here
dash.
it should be P, na? Then it is inside P cross 0, so it is P dash. ठीक है?
Yes, sir.
Okay, so we could not discuss the path algebra of QL due to time. Tomorrow, Shubhajit, uh, there is one question in the last assignment regarding the path algebra of QL. So
Yes,
probably
sir.
Shubhaj, हाँ, so Shubhajit probably will discuss it tomorrow. Okay. In the last year's assignment also there is a question related to the path algebra of QL. So if he will solve the last year's assignment, so he will you can ask the path algebra of QR there. Okay.
Yes, sir.
Okay. So do attend his like session tomorrow. He's going to discuss the next 7 questions. In the first 8 questions, do you have any doubt in any of the question?
No, sir. Clear.
Okay. So then we can stop it here, and we will meet in the next on the next Friday at the same time from 6 to 7. ठीक है?
Thank you, sir. Thank you so much.
Okay. Thank you, Shalini. ठीक है फिर ना?